Hi friends, our today's lesson is open and closed sets. But in order to understand it clearly, we firstly should learn the limit points and isolated points. So, what is limit points? And there is one definition. Suppose we have a set, real number set, and A is a subset of real number set. A point C from R is called a limit point of A. A point C from R is called a limit point of A if there is a sequence delta n in A with delta n is not 0 for every n from n, and such that the sequence delta n converges to C. So if our C, what is our main, we have three main promises. First is, this is first, delta n, the sequence delta n should be from A. The second promise is delta n should not be equal to C, and delta n, the sequence, should be converged to C. So if these three conditions are satisfied, then we can say that C is a limit point of A. A point C from A, which is not a limit point, is called an isolated point. So from this definition, we can understand that isolated points is not limit points. This is a little remark here. Limit points may lie outside of a set A, but isolated points must be in the set. So this is our set. This is our first example. As you see, this is 1 over 2, 1 over 3, 1 over 4, 1 over 9, 1 over 8, 1 over 27, and etc. All the points that are inside of this set are called isolated point. Our claim is 0 is a limit point of A. The limit point of this set is 0. Let's look. As you see, we say that 0, our limit point, is not from A. Yes, 0 is not in the set A. Limit points need not belong to the set. It means that if we have any limit point, it can be in the set or it cannot be a part of the set. Okay. So here 0 is not limit point, is not belong to the set. We must find a sequence of points in A which converges to 0, but not of the point of our sequence can be 0. So let's consider a sequence delta n in A. Our sequence can be any subset of the A. For example, let's take delta n 1 over 3, 1 over 9, 1 over 27, and etc. As you see, it converges to 0. 0 is not in this set, inside of this set, and in this set, there is no 0. Okay? Our first claim, delta n in A. Yes, delta n is in A. Yes, it is satisfied. Our second condition, delta n is not equal to our limit point. Yes, delta n is not equal to, there is no zero inside of this set, okay? And our third condition is that delta n converges to C. Yes, all of these three conditions are satisfied, so we can say that 0 is a limit point of A. Or another sequence, 1 over 2, 1 over 4, 1 over 8, also first condition is satisfied, our first rule is satisfied. Yes, it is from our main set. Yes, and there is no zero inside of this set. Yes, this set is not equal to 0, but it converges to 0. So as you see, our all three conditions are satisfied, so we can say that the set Bn is as the set Bn is the subset of A and all these three conditions are satisfied, 0 is a limit point of Bn too. So here we have a question. Is 1 over 2 a limit point of A? Is 1 over 2 a limit point of A? As you can see here, 1 over 2 is inside of our main set, and we say that limit point can be inside of the set or cannot be. So we should find the sequence delta n from A such that, here is A, delta n should not be equal to our limit point if it is limit point. So delta n should not be equal to 1 over 2. And delta n needs to converge to 1 over 2. So the answer is, since 1 over 2 is in A, 1 over 2 is in our main set A, but is not a limit point A, then 1 over 2 must be an isolated point. Here is the answer. All the isolated points of this set is 1 over 2, 1 over 3, 1 over 4, 1 over 9, 1 over 8, 1 over 27. But here the limit point is only 0, not the elements of this set are not limit points, cannot be. These elements, any of them, cannot be the limit point. They are just isolated points. Another example. Our set is neither, as you can see, our interval is neither open nor closed. Yes, 2 is included, but 1 is not included. Let's see. Our question is 2 a limit point of A? As you can see, 2 is inside of our main set. Always try to use the version of 1 over A. This version is always a good option, okay? So consider any subset, any sequence from this main set. 2 minus 1 over 2, 1 over n, and n start with 2. So then our sequence will be, if we plug 2 here, 1 over 2, 2 minus 1 over 2, 2 minus 1 over 3, 2 minus 1 over 4, and etc. What is the results? 1.5 and so on. Yes. Does it converge to 2? Yes. This sequence converges to 2. Here is our three main rules. Our first rule is the elements of this set belongs here. Yes, belongs to this set. And here inside of this set there is no 2. This sequence is not equal to 2. Our second condition, our second rule is satisfied, and our third rule, this sequence converges to 2. Yes, so 2 is a limit point. And here our another question, is 1 a limit point of A? Let's show the example. Let's see our main set. As you see, 1 is not included to this set. Yes? And here is our second sequence. Consider any sequence you want. I just wanna try this sequence, okay? If we put 1, if we plug 1 here, our sequence will start with 2. 1 plus 1 is equal to 2. Yes. 1 plus 1 over 2, 1 plus 1 over 3, and etc. Does it converge to 0? Look please. 2, 1.5, if we want write it as decimal. 1 plus 1 over 3, 1 plus 1 over 4. Yes, you see that this sequence converts to 1. It starts with 2, but it gets less. Yes, and it converts to 1. But it can never be 1. Yes, our here we cannot write 1 because 1 can never be the element of this set. So yes, 1 is a limit point of A. So our another question, let X be from A. It means that here in the middle of 1, from 1 to 2, in the middle of 1 and 2, it can be 1.5 or 1.75 and etc. Any x between 1 and 2. Any x from A is x a limit point of A. Using some version of, as I said, 1 over n is always a good option. For one strategy, if our x is between 1 and 1.5, as you see, 3 over 2 is equal to 1.5. Then let's try this sequence, choosing k carefully. For example, x plus let it be 100. X plus 1 over 100, x plus 1 over 101, x plus 1 over 102. Does it convert to x? Does it convert to x? Let's think. But if x is between 3 over 2 and 2, let's try this sequence. Again, you can take n as 1,000, 100. Okay, let's take it as 1000. X minus 1 over 1000, x minus 1 over 1001, x minus 1 over 1002. Is it is x limit point here? So we can try it yourself. Try it yourself and answer me, please. Try it yourself. So here limit points is 1 and 2, but isolated points is none. Why? Because any point from A can be a limit point. Okay, 1 over 5, 1.5, 1.7, 1.95, and etc. Any point from this set can be limit points, and we say that limit points cannot be isolated points. So let's try another example. Our third example. Let A be the set, the numbers from 1 to 5. As you see, 1 and 5 are also included. Question: is 3 a limit point of A? Is 3 a limit point of A? Is sequence delta n in A? We want to find a sequence delta n in A with delta n as our first rule. Delta n, first rule, should be from A. Delta n should not be equal to limit point 3, but it should converge to 3. Let's look at our solution. So our set is consists of elements from 1 to 5, and we consider 3 as our limit point. Let's look, does it true or false? So here is a neighborhood. Here is a neighborhood of 3, and it contains no other element of A. Okay, the neighborhood we can find any neighborhood. It can be like that, like that, like that. If any neighborhood of 3 doesn't contain the element of A, then we say that it is not a limit point. So 3 is an isolated point. Similarly, 1, 2, 3, 4, 5, all these elements are isolated, not limit point. They are just isolated point. And this is our another example. Let me show you. This is the answer of our first example. Okay, so 0. We can find a neighborhood. Every neighborhood of 0 contains a point of A. As you see, 1 over 27 is a point of A. Here is a point of A. And the neighborhood of 0 contains this point. So 0 is a limit point. Or another point, 1 over 3. This is a neighborhood of 1 over 3. This neighborhood of 1 over 3 contains no other element of A. Therefore, 1 over 3 is isolated, okay? Not limit point. This is just isolated point because the neighborhood of 1 over 3 contains no element. And here is the solution of our second example. This solution of this example. Here this is our line. It starts with 1. As you see, this is open. It starts with open brace. 1 is not included to our set. And it ends with this brace, this closed brace. And 2 is from this set, as you see. So this is a neighborhood. This is a neighborhood of 1, and as you can see, any neighborhood, any little or large neighborhood of 1 contain an element of this set. Okay, any neighborhood of 1 contain. So 1 is a limit point of A, and every neighborhood of 2 contains a point in A other than 2. As you see, 2 is inside of this set. But we can find any neighborhood of 2 that contains element from A other than 2. So 2 is a limit point. Let's consider X, our third question, X from A. Is X a limit point? If we pick any point X, every neighborhood of X contains a point in A other than X. As you see, this interval, or all points in this interval are from A, and any neighborhood of X contains all the elements from A. So X is a limit point. If we have Y here, all the neighborhood of Y contains all the elements of A. So Y, Z may be here. Any point from this interval can be a limit point. So the elements of this set are not isolated points. All the elements of this set are limit points, and isolated points are none. final topic, open and close set. As we learned the limit points and isolated points, so now we can learn the open and close sets better. So an open set is identical to its interior. What does it mean? Let's draw a line. This is a line, okay, and this is any set, any open set inside of the line, okay, and it doesn't matter where we take a point, okay, it doesn't matter how close we go to the edge, we can always find an open set. We can always find an open set. We can always create an open set that is completely contained inside of our main large set, okay? It doesn't matter how closely we go to the edge. There is always a set that contains all elements of our large set. But what is closed set? Closed set contains all of its limit points, okay? If you had some kind of sequence of elements from this set, the limit of this sequence would be a point inside of that set. So here is some definitions of closed set. The set of all limit points of E is called the derived set of E and denoted by E prime, okay? And if all limit points of E is included to set E, then E is called closed set, okay? If all limit points of E, the set E prime, is included to our main set, then this is closed set. If every point of E is limit point of E, then E is called dense in itself, okay? If every point of E is included in E prime, then E is called dense itself. If E is equal to E prime, is it clearly seen? If E is equal to E prime, then E is called perfect set, okay? E union E prime is called the closure of the set and is denoted by that. From above definition, the set is closed if it contains all its limit points. There is no isolated point in set which is dense in itself. A perfect set is closed and dense in itself, okay? The perfect set is both dense and closed because all these two conditions are satisfied here. Look at this set, 1, 1/2, 1/3, and etc. This set is neither closed nor dense in itself because its limit point is 0. The limit point is this set is 0, and 0 is not from E prime. Okay, E prime is not included to E, so E is not included to E prime.